Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 26th of June, 2025 T 15 hours, 9 minutes and 21 seconds, .0000Z. This paper, published just a few days ago, reveals that even top vision language models like GPT-4o score less than 60% on understanding basic cinematic language. The paper is titled ShotBench, Expert-Level Cinematic Understanding in Vision Language Models, and it introduces a new, smaller model that actually beats the big proprietary players. To tackle this, the authors created a new expert-annotated benchmark and a large-scale dataset to train models specifically on the language of filmmaking. Also, the authors shared their work on GitHub. If you head over to the project page, you'll find the repository is set up, but the full implementation is marked as coming soon. So you can start the project now and keep an eye out for when the code officially drops. On Hugging Face, you can find the 3 billion and 7 billion parameter models, complete with code examples for analyzing cinematic shots in both images and videos. Alright, so to really get a feel for what this new ShotBench benchmark tests, this figure gives a great overview. It breaks down cinematic language into 8 core dimensions. We're talking about things like shot size, from a wide shot to a medium close-up, camera angle, like a low-angle shot to make a character look powerful, and even camera movement, showing a zoom-in or a tilt-up. It also covers lighting, lens size, and composition. This is all about testing for fine-grained visual terminology alignment. Basically, can the model connect the right filmmaking term to what it's seeing? Building on those 8 dimensions, this table really drives home why a new benchmark was needed. It compares ShotBench against 5 other existing cinematography benchmarks. As you can see, the others are pretty limited. For example, Movie Shots and MovieNet only cover shot size and camera movement, while Cinematography is a bit better but still misses key aspects like shot framing and lighting type. The key takeaway here is that ShotBench, on the far right, is the only one that comprehensively covers all 8 dimensions, making it a much more rigorous test for these models. Moving to the results, this table lays out the scores for 24 different vision language models on the new ShotBench, and it's a bit of a reality check. You can see the scores across all 8 cinematic dimensions, from shot size to camera movement. The striking thing is how poorly existing models perform. Even the best proprietary model, GPT-4o, scores just 59.3% on average. But then, look at the very bottom row. The author's new smaller model, ShotVL, hits an average of 65.1%, outperforming every other model. So to dig a little deeper into why a powerful model like GPT-4o struggles, these 2 charts, called confusion matrices, are very revealing. A confusion matrix is basically a grid that shows us not just if a model was wrong, but how it was wrong, what it confused one thing for. Looking at shot size on the left, when the real answer was a medium shot, GPT-4o guessed it was a medium close-up over 36% of the time. And for lens size on the right, it frequently mistook a medium lens for a wide one. This highlights that fine-grained visual distinction problem perfectly. So, to wrap up, it's clear that even the most advanced models have a blind spot when it comes to the language of cinema. This work introduces not just a tough new benchmark to expose this weakness, but also a specialized dataset and a smaller, more efficient model that actually beats the giants. The key to their success was a 2-stage training process, using supervised fine-tuning, which is like giving the model a specialized study guide, followed by group relative policy optimization, an advanced technique that helps the model learn from comparing different answers. That's all for this week's AI Research Roundup. Thanks for tuning in.